this, we have to think about how is the fluid and the solids that are in suspension going to flow around these fittings. We want to keep nice long radius bends. We want to keep everything nice and smooth, nice and relaxed, right? Everything graded downward by gravity. That's for the most part. That's most of the plumbing drain waste systems we deal with. However, these type of fittings make our lives simpler, make our jobs easier. Look at that. These are called double pattern fittings. Now, let me explain. If I have this fitting right here in the middle, it's called a double quarter bend. We know what a quarter bend is, right? It's a 90-degree, right? So I got like two 90s, right? One this way and one this way. Hey, Carla, if I had a house here, right, and I had a bathroom group over on this side of the house, I could run my 3-inch pipe in this way, right, Carla? And then, right, Don, if I had another bathroom over here on this side of the house, a bathroom group, I could run my 3-inch pipe this way, all into one fitting and maybe go down with a 3-inch or a 4-inch stack. Boy, does that make my life easy, doesn't it? Man, I don't have to cobble fittings together and tees, sanitary tees in the 90. My joints are less here, right? So I could use another fitting like this here. Now look at the difference here. Look at the difference here. You see this long radius here? This long radius? This is called a double combination Y and eighth bend. Why could it possibly be called a Y? Well, if I come up, it starts off on a 45-degree angle. You see this? Comes up, off on a 45-degree, and then it breaks down on a 45-degree and a long radius, right? Combination Y, right? Y, and an eighth bend to get me back down onto 90 degrees, right? Beautiful. Isn't that nice? Then I got another connection up here where I could go up to the next story or the next vertical elevation. All right, now, next, we're getting somewhere now. We're getting closer to that most violated fitting, and I'm going to show you how this works here in a few slides. This fitting right here, it feels like an old Clint Eastwood movie, The Good, the Bad, and the Ugly. Oh boy, I'll tell you what, this fitting here is a great fitting when you know how to use it. It's a bad fitting. It's an ugly fitting when you don't use it right. And I have to say, you know, a lot of plumbers know how to use this fitting, but homeowners doing their own plumbing seem to make mistakes. And I'll show you how this works. Now, a sanitary tee, take a look at the pattern of the sanitary tee. Look at the flow. If I'm flowing horizontal to vertical, right, that's fine. It looks like it'll go down just fine. It'll look like it goes down just fine on a vertical to vertical because it's just like a piece of pipe, isn't it? It's flowing straight through, right? Vertical, downward, right through the fitting. So far, so good. I could use it in that orientation, and I could use it in horizontal to vertical if I have the right orientation. You see this right here, that radius? That's exactly the pattern that you want to see. You can't flip it over and go down this way because of that sharp edge right there. It only flows horizontally to vertical in one direction, okay? Now, right here, this is called a Y. Makes sense, right? Because it looks like a Y. It's 45-degree. This is a sanitary tee, either a reducing or a double. Now, a double sanitary tee like this, I can put a water closet on each side of the sanitary tee. However, there's always a however. If I put a water closet on this side over here for a bathroom to catch my water closet, I flush it and it goes down beautiful. Put another water closet here, I flush it, it goes down beautiful. But if my water closet piping gets too close to the tee here, guess what's going to happen if I use a double pattern sanitary tee? When I flush the water closet, it may in turn go across and bubble up into the adjacent water closet on the other side of the fitting. Can you imagine that? That wouldn't be too healthy. That wouldn't be too sanitary. Let me show you a code section that I'm talking about here. Right here. Right here. You see this code section right here? Horizontal to vertical multiple connection fittings. Take a look at the exception right here. It's in section 3005.1.1, back-to-back water closet connections, just like this, right? We need to make sure that we have at least 18 inches or greater before we put a 90 and go into a floor flange for the toilet. I need this amount of room for that fluid to settle out and go and be kind of like, not turbulent, if you will, but a little bit laminar, so it'll flow nice all the way down the drain. If I get any closer, ladies and gentlemen, with this double pattern T, this sanitary T, it's got the susceptibility to move across and go up into the water closet on the other side of the wall. So you need that 18 inches or greater. Now I don't need that 18 inches if I go with this type of a fitting. Look at the pattern of the fitting. You see this? It's called a double TY, or that 1/8 inch fitting that I showed you where it was the combination Y and 1/8 bend, right? Look at the radius on this thing, right? I could get a little bit closer to the wall, so my tank is a little bit closer to the wall. When I flush this, I've got a nice long radius where it's going to be directed downward. It does not have the susceptibility, due to gravity, of course, to come up and back up into that toilet, right? Unless I got a blockage here, right? So this is a better fitting if you want to get the toilet a little bit closer if you're using a double pattern fitting. Remember, if you use a double pattern sanitary T, you need at least 18 inches away from that fitting. And you can imagine the tank is going to be pretty darn far off the wall. That's not going to be too good, right? You may want to use one of these TY fittings here, right? Or combination 1/8 bend, combination Y 1/8 bend, kind of like this here. Good idea? I think it's a great idea. You will catch this in the field, I guarantee it, where people are using double sanitary Ts and they're less than 18 inches. Go to this code section to the exception, and you will cite that code section and explain to the plumber exactly how this works, okay? That's the game. You have fittings that look like this here, where we have low heel and high heel inlets that can be used, maybe for wet venting purposes, maybe to catch like lavatories off of a water closet, right? Maybe I got a water closet here. I'll catch a lavatory off of here, 1.5 to 3 inch. These are great fittings here because I don't have to cobble a whole bunch of fittings in like upstream to make these connections. I'll use these nice pattern type fittings. All right, enough of that dissertation. Here's where we're going to go. You have a table in your code book. This is the table. X marks the spot. All right, let's play the game. You have the type of fitting on the left-hand side. You have the change of direction in the body of the table. The orientation of the flow is given right here. Horizontal flow to vertical flow to horizontal flow, and finally, horizontal flow to horizontal flow. So using my great engineering expertise here, I drew up some stick figures for you. How about that, right? And that's all it is. They're just simple little lines. Look at this. I've got something here. I say to myself, here's a vertical drain coming down from maybe a story above. It goes through a sanitary T vertically, comes down through a long sweep, and then goes horizontal. All right. When you see a piping diagram like this, or whether you're in the field, you need to look at this and say, are these fittings in the right orientation? Do they work? As a plumbing inspector, you have to know this. I'm going horizontal into a sanitary T and going vertical down. Can I use a sanitary T to go horizontal to vertical? Horizontal to vertical, sanitary T, X marks the spot, but I see a note C. What does note C tell me? What does note C tell me? Somebody weigh in.
Check your horizontal to vertical the multiple connection fittings.
Yeah, it says right here, the limitation on multiple connection fittings. You know what that code section is? Do you remember that? Yeah, it's that 18-inch thing right here, right? It's this thing right here. It says, hey, be careful. You better make sure that you're 18 inches away if you use a double pattern fitting. We already went over that. Fantastic. So I ask you a question, ladies and gentlemen. I don't have to worry about a double pattern thing here, so I don't have to worry about footnote C, do I? Absolutely not. So in this orientation, I've got a horizontal drain coming into the branch of the T, feeding horizontal to vertical. It will work all day long. X marks the spot. However, I go straight down and I go into a long sweep here. This fitting is called a long sweep. Can I go vertical to horizontal with a long sweep fitting? Can I? Yes. Vertical to horizontal.
Yes.
Go vertical to horizontal. Here's my long sweep. X marks the spot. Well, you know what? That long sweep fitting, that plumbing supply house costs too much for that long sweep. Can I get away with a short sweep 90? Can I get away with a short sweep fitting here?
No. No.
2 inches smaller.
Clean out. Unless you are a clean out.
Yeah, so I have vertical to horizontal, right? Vertical to horizontal for a short sweep. Man, I got 2 footnotes here. Wow, this one here is only for a 2-inch, right? And then footnote B tells me it's 3 inch or larger. I don't know. We'll have to figure that one out depending upon the pipe size, right? Either way, my long sweep will work. Now look at this one here. I go horizontal to horizontal in a Y. See this? I go horizontal to horizontal in a Y. Can I do that?
Yes.
Horizontal to horizontal. I go to the Y. X marks the spot. Fantastic. Here's where everybody goes wrong when they use the sanitary T. You use the sanitary T like this. It's called a T on its back.
Cannot go.
T on its back. Can I go vertical to horizontal with the sanitary T?
No, that one don't work.
That does not work.
No, because the heavies are going to hit right there.
What's going to happen here?
Yeah, it's going to get plugged. All the heavies are going to stop right there.
You got it. You got it all day long, Frank. My main man, Frank, hit it right on the head. You know what's going to happen? All this stuff is just going to slam down right on the back of the T. You're going to get a huge amount of turbulence and a major blockage there every single day that you flush the toilets from above, right? You can't use the T like this in a vertical to horizontal. How about if I just kind of maybe tip this T over this way and used it like the Y here? Use a T here instead of a Y, go horizontal to horizontal. Instead of a Y, can I go horizontal into the T and then horizontal back out?
Only if you give him like a 45 slant is permitted.
No, I want to use a sanitary T, Frank. I want to use a sanitary T right here instead of a Y. Horizontal in, horizontal out.
No, it's the same thing. It's going to hit.
Horizontal to horizontal. See that line?
Yep.
That means no, sir, no, ma'am. You cannot do that. Does this help? Just these little goofy diagrams here, just help understand the flow and the fitting orientation. This is how you apply the table, ladies and gentlemen. This is how you apply the table out in the field when you do the inspections. On a drawing, you know, as plans examiners, we can't see this stuff like this. Normally we're given a 2-dimensional drawing and they don't show us the orientations of the fitting. It's understood that qualified people are going to put this stuff in according to the code. Your job as a plumbing inspector is to go out there, look at the approved drawings, and apply your knowledge based upon the code to ascertain what's been built out in the field. In this case, we're looking at the fittings, we're looking at the flow, and we're looking at the pipe size limitations as well for these particular pipe fittings. All right, I'm going to kind of go off on a tangent here and say, Just what I said, I don't know, a couple hours ago. Do you remember I made a statement and I said you can never, ever reduce the piping in the direction of flow? Do you remember that? I was pretty adamant about that. Is it ringing a bell? If not, I'll say it again. I will say it again. You can never, ever reduce the diameter of the piping in the direction of the flow. And I said, well, there's a couple of exceptions, right? Let me see here. Here's the exceptions right here. This is the only way you can do it, not only in the residential code, but the commercial international plumbing code right here. Here it is right here, right? Drainage piping, size reduction in the direction of flow. It says the size of the drainage piping shall not be reduced in the direction of flow. The following shall not be considered a reduction in size in the direction of flow. Item number 1, a 4-inch by 3-inch water closet flange. Here's a water closet flange. This is the part that gets screwed to the floor. Sometimes what we have is a toilet will come with like a 4-inch opening, which will need a big 4-inch type of a floor flange. And then we can reduce down to a 3-inch socket type fitting to make our connection with PVC or ABS 3-inch pipe. So it's a reduction from 4 inches to 3 inches, which is allowed by item number 1. Item number 2 gives me another way that I can reduce in the direction of flow. It's where we use a reducing closet bend. Isn't it amazing how this plumbing code talks? It's a reducing 90-degree fitting, where my toilet manufacturer comes with a 4-inch outlet that I've got to bring up onto my 4-inch closet flange. And then my piping is only designed for 3 inches, which will carry the drainage fixture unit for a toilet all day long in residential. So I'll reduce from 4 inches to 3 inches according to item number 2. The last one is what we call an offset flange. An offset flange. This is where we take a floor flange and sometimes you need to offset it. In other words, it's offset one way. Say my piping came up in the wrong center line and I got to offset my floor flange over a couple of inches. Well, that serves as a little bit of a reduction on that offset area, and that is an allowable reduction called item number 3, an offset closet flange. Okay, now you know each and every one of the criteria here for approved offsets in 3 areas. Okay, let's move on. Some of the joints that you'll see in drain, waste, and vent. This is old style piping. We don't do this lead anymore. As you know, lead is considered now a hazardous material, rightly so. But years ago, you know, plumbers used to put this stuff together. They did this before I got involved in the trade. I worked on some of this stuff, but I never put the stuff in brand new. Always retrofitted this. But what you do is you actually pack it with oakum. It's this real sticky stuff, like a string and sticky oakum, basically, and you pack this stuff in, and you actually pour the joint. They call it pouring a molten lead joint. This actually makes a watertight seal or a drain-tight seal accordingly. This is cast iron pipe, ladies and gentlemen. What we do now, we still use cast iron pipe, but normally the way that we put it together now is with what we call elastomeric type couplings here, where we have their mechanical fittings. They look like radiator clamps, if you will, and they have a rubberized type of a boot here with a little center stop here, and you actually crank these things down over the cast iron pipe. Now they make a whole bunch of these things. They make them for conversions of PVC to cast iron, right? Clay pipe, vitrified clay pipe to cast iron, vitrified clay pipe to PVC. These are beautiful, beautiful fittings. I have a picture of a job that we did several years ago. This is a no hub cast iron job for a commercial building. And this is how it looks here. These are the elastomeric couplings here, or no hub couplings. And you actually snap the cast iron to its end-to-end measurement, and of course put these elastomeric couplings on to make the joint. Pretty simple mechanical joints. right? Cast iron is still used in residential, but not in the whole drainage system. It's used because its sound deadening properties are very good. Because can you imagine if you're all sitting in my living room right now, ladies and gentlemen, and I had a stack that runs down the adjacent wall in my dining room per se, and we're all having dinner at my big grand dining room table, right? And all of a sudden somebody flushes the toilet upstairs, right? And everybody's looking around because they hear all that water, swirling down the pipe, right? So a lot of people use cast iron to deaden the sound in a lot of cases like that. All right. What else? We've got to get to this portion here. All right. How are we doing? We're doing good. Proper vent. So when we get into the venting here, this is what I want to show you here. There is no slope that's given to you in the code, except, remember what a vent is for? Remember at the beginning of the seminar, I told you that maybe this dry vent, it's got to go through the roof so we could get that atmospheric reference or that air pressure into the system for equilibrium regarding the trap seals. Well, when you run vent piping, remember the dashed line, that's the dry vent. So if I came off of a kitchen sink here, sanitary T, here's my fixture drain, right? My fixture drain is the horizontal pipe to a sanitary T. I come up here with my dry vent. The code says that you will grade the vent piping towards the direction of the drainage system, just in case you have some condensate built up, right? Or maybe it rains into the pipe that's sticking through the roof, right? You want to have that thing drain all the way down into the drain for condensate and any other moisture that builds up in the pipe. So if this is a beam here, I want to grade the pipe downward on the beam, go under the beam, and then grade it downward towards another vent. That way any kind of condensate or additional moisture would trickle down into the drainage system. It would not block the venting system. Take a look at this. You are never permitted to trap any type of vent piping. Ladies and gentlemen, when you go out there and you do your plumbing inspections, always look at the venting system. In order to avoid drilling a beam, you may see this. Believe me, I'm telling you, you may see this out there. You come up high on the beam, they say, okay, I'm grading it down, and then I'm going to go down, under, and up. What did I just do here? I trapped the vent pipe, didn't I? I can never get any air in there after that fills up with water, can I? After this fills up with water, it becomes a block here, doesn't it? It does not allow air to flow into that pipe, right, to provide equilibrium at this point to maintain our trap seal. Remember that equilibrium? My pipe pressure on this side of the trap, or my piping system equilibrium, air pressure, piping system pressure. I'm trying to make it equal. And if I have a trapped area here, we will fill it with water and eliminate any type of airflow. Hey, we've seen this table before. It's getting to be like a flashback again, isn't it? It is. But this table is relevant for not only water distribution piping, but drain, waste, and vent piping and tubing as well. Look at this. Same table, same requirements. Wait a minute. How about this? Another thing, deja vu, right? Instead of a water pipe coming through the foundation, right? Maybe I've got a drain, waste, and vent piping. Maybe my building drain comes through, what? 30 inches past the exterior wall, right? That's the building drainage pipe, right? So remember, 2 pipe sizes larger would be the pipe sleeve size for that as well. All right, a couple more things here as we go along. Task 2, we have what's called traps. We went over this initially this morning, so you know about this. Chapter 32 deals with trap seals and trap requirements. And as you know from this morning, we have the dimension that is measured from the top of the dip of the trap, from that point all the way up to what we call the crown weir. This is the seal of the trap that cannot be less than 2 inches and not more than 4 inches. So where do we see these things at here? Well, in water closets, this is an inherent trap that's actually cast into the water closet. Take a look at this section view. Do you see this? Take a good look at this here. Sewer gases exist on this side of the system. They cannot go any further than that point because of the water level within the water closet. When you flush the toilet, the contents are evacuated. They go up, around, and down. And if it's a tank-type toilet, you refill the bowl up to this elevation and you make the seal all over again. Sometimes we have situations where we have a floor drain, ladies and gentlemen. We do not want the trap seal to evaporate due to the trap or the floor drain not being utilized. This is maybe an application where it's a floor drain for an air conditioning / furnace. And if you have a 80% or a category 1 type furnace, where it is a non-condensing furnace, it does not condense, it doesn't need a drain, then this floor drain would not be utilized all winter long. In which case that maybe our trap seal may evaporate. Well, this brings up the necessity for what we call trap primers. In other words, I need to supply a little bit of water just to make sure I keep my trap filled with water. Because if my trap evaporates, what's going to happen? What's going to happen if I lose my water seal here in the floor drain?
Sewer gas.
We're going to get sewer gas migrating back into the livable, habitable space.
Jerry, I heard that cooking oil, they can throw in cooking oil there. What do you think about that? On those
Oil?
Cooking oil? That
Yeah, I
doesn't
know. We've heard
evaporate.
that for years. We've heard that
Yeah,
for
I heard
years.
that.
No, it's not in the code, so, you know, I
not.
wouldn't do it.
No, it's not. I just heard that. They
Yeah.
use that so it doesn't dry.
Yeah, yeah. It's
Not a good practice.
no, it's not a good practice, you know. You never know. I mean, if you live in cold areas, it could solidify and not good. So water. How about one of these, Frank? What do you think? Don't use the oil. I sound like a salesman, but I'm not. I'm not a salesman. How about one of these things? You stick it right in the trap, right? It's called a barrier type seal protection device. You ever see one of them Venus fly traps? You know, them flowers that eat the bugs and stuff like that? It opens and closes automatically. I think it's automated. Does that thing have a brain, the Venus fly trap? I don't know. But anyway, it kind of works like this. See this? It's got actually like 4 petals. It's got 1, 2, and then you don't see the other 2 because it's cut here. Well, when water hits this, it's called like memory rubberized stuff, right? When water hits this thing, these petals actually open like this, and it allows water to flow down into the drain. Once the water stops flowing and it stops sensing the moisture, these petals actually close and make a gas-tight seal. Again, these things are called barrier-type trap seal devices. They're rubberized and they actually fit right over 2-inch shower drains, 3-inch floor drains. You could buy these things in all sizes, but it will make a gas-tight seal so that when maybe a trap maybe dries up or something like that, it will not allow gas to penetrate beyond the seal here that it makes from these 4 little petals here. Isn't that cool? That's really neat stuff, isn't it? Been around for a while, maybe about 10 years.
That seems like the material they use in the toilet, you know, the toilet tank, the flapper, the one that seals.
Yeah, it's pretty similar to that, Frank. Yeah, it's pretty similar to that. But if you ever get a chance, go on like Google or YouTube or something. These things are great stuff.
That's a good thing to look for.
And you know what? It's allowed by code. Not only is it allowed in the residential code, but it's allowed in the commercial code too. Now, if I want to talk about economics and cost, look at this. It'll cost me less to provide that thing and stick it over a floor drain than pipe in a water line, right? Like a copper type trap primer into the drain here and tie this into the potable water system. I mean, the cost of this thing is a lot more than going in to the plumbing supply house and picking up one of these things and forcing it over to the drain, like the floor drain.
You bet.
I think it's great. I feel like a salesman, but I'm not, you know, I'm practical,
Oh,
right? Okay. All right. Take a look at this. This is a great table. This is a great table. Highlight this table in your code. Look at this. This table is giving you a plumbing fixture. I'm in chapter 32. This is the trap chapter. I'm going to trap you up here. The plumbing fixture is given to you here, and the trap size minimum is given to you. I love this. If I have a bidet, it tells me that the minimum trap size is 1.25 inches. Fantastic. Floor drain, your minimum trap size is 2 inches, nothing smaller. Lavatory, fancy word for the bathroom sink, 1.25 inches. Look at what I've got here. You know, only in America, ladies and gentlemen, only in America, we keep ourselves cleaner and cleaner every single year. Look at this. Have you ever been in some of these big houses that have these gigantic showers in them with a whole bunch of nozzles that come out of the wall, right? Those water nozzles and the shower heads that spray water all over the place. Look at this. You add up all the nozzles and the shower head, the body sprays, whatever the heck they're called, and you come up with a total gallon per minute. Once you come up with the full flow that you've gotten from the nozzles and the shower head, you can come over here and size the trap size and the piping for that particular trap. So I'm going to give you an example. Let's say that, I don't know, Jerry's got this great granite shower with all these glass panels, and it's like 8 foot by 4 foot in dimension. It's a huge shower. I don't know what I do in there, but I got a whole bunch of nozzles and shower heads and everything. And I calculated my nozzles and shower heads to come up to about 23 gallons per minute. 23 gallons per minute. What trap size do I need for my shower drain?
4. Oh, 3. 3.
23 gallons per minute.
3 inch.
3 inch. So I'm more than 12.3, but I'm less than 25.8. It's a 3 inch trap. So that's basically what I need. Pretty simple. I like it. Hey, wait a minute. Trap size for a water closet. What's going on with this? It says C note A. We know that normally that the water closets have an inherent trap in them, and there it is right there, just referencing that. All right, this particular table, I'm showing you some really cool tables because we're going to apply them before this presentation is all over with. And here's what we look at right here. This distance right here, it's called distance of fixture trap from the vent. We call it a trap arm. That's what we call it, a trap arm, right? So here's the size of the trap, 1.25 inches all the way up to 4 inches. The slope per foot is given to you. It's all 1/4 inch until you get to 3 inch pipe. Then it slopes down to 1/8 inch. The distance from the trap. All right, now this is called the trap arm. I'm going to show you how this works. So for an 1.25 inch trap pitched at 1/4 inch per foot, I'm allowed to go 5 feet from the trap into maybe my vent connection. Okay, if I got an 1.5 inch pipe pitched at 1/4 inch per foot, I'm allowed to go 6 feet away. Let me show you what we're looking at. Just look at this picture here. See this picture? I've got a standpipe here. This is a 2-inch standpipe, 2-inch trap. And from this point to my connection to the vent, if I'm 1/4 inch per foot, how long can I be from this point to the connection to the vent for a 2-inch pipe? I don't know. I'm going to go back to the table and figure it out. 2-inch pipe, 1/4 inch per foot. I'm allowed to go 8 feet away, ladies and gentlemen. This horizontal piece, we call it the what? The fixture drain, fixture drain pipe, can be 8 feet away. 8 feet away. We call this the trap arm. That's how we call it, the trap arm. Okay. So that's what that table's all about there. I put this section up here for your knowledge. Please write this section down, highlight it in your code book. You will see standpipes all the time for clothes washing machines. These are the criteria for the minimum and maximum height of standpipes and laundry trays that get attached to those, okay? Here's just a graphic representation of that table that I just showed you, right? Basically what we want to do is we want to keep a little bit of airspace in here, but not so much that when I pitch that pipe over the distance that I'm going to lose total airspace. That's what this is based on. It's based on pipe diameter and horizontal length based on a pitch of 1/4 inch per foot. Yes. This one right here? Yeah. No. Remember, no. Yeah, that's where we have a double sanitary tee. Remember, that's for a double pattern sanitary tee is where the 18 inches comes in for water closets. Yeah. All right. So this is the maximum trap arm that I'm allowed to use, right? According to that table, right? Here's the table, right? This is the maximum distance. Don't you remember what the minimum distance was? Remember that crown venting I showed you early this morning? The crown vent, I need to be 2 pipe diameters away from the trap before I go into a vent. 2 pipe diameters, yeah. So we have the minimum already taken care of. I want to show you this. You see this? If I use that table and utilize that table on the maximum distance from the trap to the vent, I can use this particular graphic. Look at this here. We call this system a wet vent. This is called a wet vent system. And I'm going to go over this with you, probably the last item of the day here as we finish this up. I'm going to go over this briefly with you. We're going to take our last 10-minute break and we're going to come back and finish up. So I want you to look at this, a tub right here, a tub. Well, if I look in the table for a trap, minimum size for a tub, I'm probably going to find that this is 1.5 inches, right? 1.5 inches. Just to show you and prove it to you, I'm looking at the tub. Let me go back to that particular table that gave me all the trap sizes right here. 3201.7. I'm looking for a tub. Tub, bathtub right here. See this? Bathtub, 1.5 inches. Okay, cool. What's the maximum distance I can go for 1.5 inch pipe pitched at 1/4 inch per foot? 6 feet. Well, if I take that knowledge and I have an application like this, if I'm a plumbing inspector, engineer, plans examiner, I can say I have a total distance of 6 feet maximum before I tie into this pipe. And then you say, wait a minute, Jerry, there's no dry vent coming off of this. How could this be a vent? This is what we call a wet vent system. You see this right here? I've got a lavatory here that has 1 dry vent. Okay, I'm going to explain this to you and then I'm going to go over it when we get back. This dry vent is the point that starts what we call the wet vent system. It's at this point right here that we begin to oversize the pipe according to a table in chapter for venting. We start to oversize this pipe all the way down to the very last fixture on the horizontal wet vent. This horizontal piece is called the horizontal wet vent. Why is it called a wet vent? Because it carries what? Drainage, and the top part of this pipe is large enough that it carries enough air to serve as the vent for 1, 2, 3 fixtures that are attached to this horizontal wet vent. So the moral of the story is I've oversized the pipe right at the juncture of that dry vent downward and across horizontally to the last fixture on that horizontal pipe that we call the wet vent. Okay, that's how I can get away with not providing a dry vent on the shower, the tub, in the water closet. I'm going to show you how to do this. So getting back to the moral of the story where I started, the tub gave us 6 feet, because it was 1.5 inch diameter, to connect to the vent. And this is a bona fide vent now, called the wet vent system. All right. All right, let's take our last 10-minute break, and then we'll come back and I'll finish all this stuff up with you. Okay, see you in 10.